Good evening, my dear students. Today we are going to discuss about the definition of jet transform. As we have discussed in the last class, applications of jet transform. Okay, I'm going to put side heading definition of jet transform. Definition of jet transform. A jet transform, the jet transform is a powerful mathematical tool. Jet transform is a powerful mathematical tool. Powerful mathematical tool for the analysis of linear time invariant discrete time systems in the frequency domain. Now let us write down the expression for the jet transform. A jet transform of a discrete time signal is represented by capital X of Z. Capital X of Z is equal summation n is equal to minus infinity to infinity x of n into e to the power of z to the power of minus n. X of n summation n is equal to minus infinity x of n into z to the power of minus n, where z is a complex variable. In the polar form, which is represented by r into e power j omega. In the polar form, z is equal to r into e power j omega. Okay, let us substitute, at which we have the z. In place of that, we are going to substitute r into e power j omega. So n is equal to minus infinity to infinity x of n into r into e power j omega power minus n. By simplifying that, what we will get, n is equal to minus infinity to infinity x of n into r power minus n into e power minus j omega n. So for a unit circle, the radius of that circle r, where r is the radius of circle, for a unit circle r value is equal to 1. Here r is radius of unit circle. Radius is a radius of unit circle. Okay, and in addition to that, consider, so where r value is equal to 1, here r is a radius of unit circle. In addition to that, let us consider the system is causal system. Let us consider causal system. Consider a causal system. Causal system. When a system is said to be causal, when the output of a system, whenever the output of a system is depends on only present and past values of input. So according to that, x of n is equal to 0 for n value less than 0. So for that reason, let us change this into after considering a causal system, that entire one is write it as x of e power j omega is equal to summation n is equal to 0 to infinity n is equal to 0 to infinity x of, so without considering causal system whose limit n is equal to minus infinity to infinity, x of n into, by considering r value 1 power minus n into e power minus j omega n. Actually it is a two-sided sequence. Again by substituting at which we have the z, by substituting z value and by considering one-sided sequence. For example, by substituting at in place of e power j omega, by substituting z, which is n is equal to minus infinity to infinity x of n into z power minus n. It is a two-sided sequence. It is a two-sided sequence. Two-sided sequence. So now consider the causal system. So by considering the causal system, which is represented by one-sided z transform, that is represented by x suffix plus of z, which is equal summation n is equal to 0 to infinity x of n into z power minus n, which is called as one-sided z transform. It is two-sided z transform, two-sided sequence of z transform, which is also called as two-sided z transform. It is one-sided z transform, one-sided z transform. Therefore x of z, that is z transform output, is how we will get z transform of x of n. By applying z transform to the x of n, we will get z transform output x of z. So it is the conclusion of definition of z transform. Okay, thank you.